you very much for joining this session about serverless Java. And now the first thing that I'm going to do is share my screen, right? Because these days, this is the only thing that we are doing every day, sharing our screen. So thank you very much for joining this session about serverless-native Java with Quarkus. My name is Alex Soto. I work in Red Hat. And if you've got any question, when you are watching this session, maybe you've got a question some time after that session, or maybe if you are watching the session and then you get some questions, then you can ask me on Twitter. My Twitter is Alex Soto B. Feel free to follow me. And also you can send me an email at sotoboy@redhat.com. And also I'm the co-author of Testing Java Microservices and Quarkus Cookbook. So also, if you want to learn more about serverless workloads in R, Kubernetes, and OpenShift, you can download for free this book, Kinetic Cookbook, which was written by Soto and Kamesh Sampath. And basically, you can download it for free. As I said, you just need to go to developers.redhat.com, you register, and then you download it, this book and other books related to the technology. So first of all, when we are talking about serverless, we are not saying that there are no servers, right? Because the servers are still there. But what we in Red Hat or in Red Hat Developers Group understand as serverless is this definition. Basically, for us, serverless is when you're trying to, or you are deploying your applications without requiring any service management. So basically, it's just, I've got my application and I said, I want to deploy it and deploy, and that's all. I do not take care of where is the servers, which are the IPs of the servers, SSH into a server, configure the server, I don't know, all this kind of stuff that maybe you were doing in the past with monolith applications, right? Then this is something that you are not going to do with serverless. And one of the key points of serverless is not just that you do not manage all the servers, but also that you are built depending on the exact demand on that moment. This means that you can scale to 0 if you've got no demand, but when you get the first request, then your workload is increased by 1. So you've got 1 instance, and if you got more and more and more and more requests, then your service is scaled up automatically. And of course, it's also scaled down automatically if you do not receive more requests anymore. And that's how we understand serverless. So notice that one of the great things about serverless is that if you've got no requests, then it's scaled to 0, which means that you are not using memory, you're not using CPU, so you're only built for what you use. Some people ask me, okay, and when I should use microservices or when serverless or functions? Well, usually people is doing a mix of both of them, right? So usually they just have an architecture where they have some microservices and some serverless or functions on the architecture, right? But in overall, if you got some questions to decide what is best, microservices or serverless or functions to fit my problem, then it depends, right? If you want to control the life cycle of the service, if your service is a long life process, and when I said a long life process, I mean that it's a service that it's running for several months, 3 months, 4 months, 5 months. And also usually you are using some kind of request response communication approach, right? So you are just sending a request, usually using a REST API, and then you get a response, then go to microservices. But if you want that the cloud controls all the life cycle of the process, so you need to take care of how to deploy it exactly, where it's going to be deployed. I don't care if there is 1 instance or 2 instances, everything is managed automatically. If your process is a short life process, it means that, for example, you are updating every 3 days, or maybe there is some range of time where you're receiving a lot of requests to this kind of service, but then the rest of the day, this service is doing nothing. Or you are into an event-driven asynchronous communication pattern, then go to serverless or functions. Of course, as I said, you can implement microservices with event-driven asynchronous approach, and you can also implement serverless or functions using the request response pattern. Okay, that's not a rule that is written in stone, just a few points. Okay, notice that I'm saying serverless or functions because, in my opinion, a function is a serverless architecture, but not all serverless are functions. So you can implement serverless architecture without using functions. Okay, then what's happening nowadays is that probably most of you are deploying your workloads in Kubernetes, right? In the past, we've got our monolith application where you've got your all your application with its own database, and you deploy that application maybe once every 3 months, every 6 months. But now with microservices, where we are deploying several times per week, we need a way to deploy easily our workloads. And this is exactly why Kubernetes and OpenShift, because at the end OpenShift is an implementation of Kubernetes, are really shining these days, right? Because it's really, really easy to deploy any changes of our services. But then there is the next question. How can I implement serverless in Kubernetes infrastructure and in my Kubernetes cluster? Well, using Knative. Okay, Knative is just a Kubernetes-based platform to deploy and manage modern serverless workloads. Basically, what it means is that we've got Kubernetes, and we've got all the primitives like a pod, service, deployment, and so on. And what we are doing with Kinetic is building at top of these concepts the way to deploy serverless workloads. Okay, and one of the great things about Kinetic is that it's container based. Okay, so you create your container and then you deploy it. It can run anywhere, on-premise, in the cloud, or in a third-party data center, which means that you are not locking your API to a concrete vendor. For example, if you are going to use AWS Lambda, then you've got a vendor locking with Amazon Lambda. The same for Azure Functions or GCP Functions. Okay, but in case of Kinetic, there is no vendor locking. It's just Kubernetes, and Kubernetes runs anywhere, right? So it means that anywhere in any cloud, GCP, Amazon, IBM Cloud, Amazon, and so on, you can move your serverless workloads without any problem. One of the things that are really interesting about Kinetic is that you can scale to 0. It means that there is no, if there is no request, it means that there is no pod. And if there is no pod, it means that you are not using memory, you're not using CPU. So your bill is going to be less, say, less expensive, right? Because no request, no process. Then also, of course, you can scale to n pods, and this is done automatically. When you've got a traffic spike, then the system starts deploying more and more pods. Well, another thing that you have with Kinetic is that it can adopt inside built-in a configuration and revision system. It means that you can have your service deployed or your function deployed, and when you deploy a new version, instead of overriding that version, you are creating a revision. So you can always switch back to a previous version. It has some kind of in-cluster image building using Tecton. Since Knative works with container images, they are also offering with the Tecton project integration to build these Docker images for you. We've got traffic splitting. We're going to see in the demo that we can do canary releases and this kind of stuff. And of course, as I said, it has an eventing system. So this is the first demo. Everything that I'm going to show you today, the demos and the slides and so on, are available on this link, the end.dev/Knative tutorial. Here you will find not just Kinetic, the Kinetic basic stuff, but also more advanced stuff. So let's see a very quick demo now. I don't want you to, it's just to get it an overview, and then we're going deeper, no worries. Let me do the next thing. This is my namespace. The thing that I want you to notice is that there is no pod. So in my namespace, now it seems that there is nothing deployed, right? But the truth, and let me show you in this way, is that there is 2 services deployed there using Kinetic. I can do Kien. Kien is a CLI tool that comes with Kinetic, which helps us to manage all the Kinetic workloads. I can do Kien service list, and you can see that there are 2. Oops, yeah, there are 2. Well, this one I can delete this for now. I will put it up later. Notice that there are 2 services, one which is Greeter and another one that is Greeter SB. And as I said before, okay, it manages everything. So I do not need to take care about providing a URL, a port, or whatever. We'll see it in a few moments how to do that kind of thing. Then we've got Greeter. Greeter is a Quarkus application, and Greeter SB is a Greeter Spring Boot application. Both are exactly the same applications, okay, but one is in Quarkus, another one is in Spring Boot. And here I've got these scripts. Notice that here I'm just doing I want to do a call to my Quarkus application, and here I want to do a call to the Spring Boot application. And now, yes, there's no pods, and I'm going to start sending requests. And what I want you to see is how fast goes Quarkus. I'm serving requests, and after 15 requests, then Spring Boot application start delivering my requests. Okay, so you can see that. For serverless applications, using Quarkus is really great because the boot up time, which is a critical thing for a serverless application, it's really well covered. Okay, I'm going to show you later with the logs, but just now you can see that Quarkus application for serverless workloads works really, really well. I'm going to leave this watching the pods, so you'll see that in a few seconds the pods are terminating. But before that, let me show you another thing. In this case, it's my cluster is on GCP, but of course it could be any other cloud. And I've got OpenShift 4.5, and I've got installed all the dashboards and monitoring and so on. I want you to see the next UI. Wait a second, I'm going to dashboards. Okay, now I'm moving to Kinetic Serving CPU and Usage, and what I want you to see is here. Okay, this is now. This is my Greeter application, the application that it's been done with Quarkus. It just takes more or less 15 megabytes of RAM. Okay, this is my application, and it just requires this. Okay, but what's happening if I move to the Spring Boot application? Okay, in the case of a Spring Boot application, this is the green one, this one. It requires 250 megabytes of RAM. Yeah. So in case of Quarkus versus Spring Boot, it's not only about the boot time, also about the memory. One is like using 20 megabytes of RAM. The other one is like 250 megabytes of RAM. So keep in mind these 2 values, the memory and the boot up time, especially in the case of serverless applications. Remember that we are always talking about serverless applications. Then let's continue with the slides now that you've seen that, oh, it's really nice, this Knative and Quarkus stuff. Again, before we continue, notice that now I've not done anything at all, and notice how the pod has been scaled to 0. Okay, so no requests, no more work, work to be done. Then the system scales to 0. And now, yes. So what we have seen now is Kinetic Serving. Kinetic Serving is a part of the Kinetic which are used when we are dealing with request response communications approach, right? You've seen that I've sent a request and I was waiting for a response. It's something that is totally synchronous. This is what Kinetic Serving part takes care, right? If you think about traditional Kubernetes deployment, you know that we've got a deployment, we've got replica sets takes care of our pods, and then we've got the service that acts as a load balancer through all these pods, providing an static IP and a static DNS name. But when we add on top of that Kinetic Serving, we've got something like this. We've got the service. Notice that this service is not a normal service. It's a Kinetic service that manages a configuration. This configuration has revisions because, as I said before, thanks to Kinetic, we've got the concept of revision. So every time that we deploy a new version of the service, then it's not deleted, but stored. Notice that also it creates a root. You've seen when I've done a KN service list, right, that there wasn't a URL of the service. I've not done anything at all. It was automatically created for me because this is something that needs to be done by Kinetic. And then, of course, as I said, all these concepts are built atop of the already known Kubernetes concepts like deployment, replica sets, pods, and services. So if you see some quotes about Java and Spring Boot, they say that a Spring is designed for long-running services, and lambdas are for literally functions that I call and then are gone. Okay, this is one of the things that we need to see all the time. Okay, if you're going to run a long-running service, then it's fine to go to a Spring or JVM or any JVM technology. But what's happening when we go to the land and see the second quote says the bigger problem with using the Spring and Java in general is the memory usage, right? We are assuming that the memory is abundant and it's cheap, but in the cases of serverless workloads, that's not true. Memory is not cheap, and the environment to run serverless workloads are usually constrained by CPU usage and memory usage. So we need a technology that it's not using too much memory, right? And this is exactly what you've seen in Quarkus. We are only using 20-something megabytes of RAM. And the third quote says the problem with Java and so on is the startup time. Okay, but you've seen that now we are starting really, really fast. And in a few moments, I will show you the numbers. So what is Quarkus? Well, Quarkus is a framework for writing serverless workloads, which is supersonic because it works pretty fast. It's superdynamic because it consumes so few memory, and it's in Java, especially using enterprise Java. And it works really fast because we are using RAL-VM. And basically what you need to think about RAL-VM is that it's just a way to compile my runner jar into a native executable, right? I know that I do a lot, it does a lot of more things RAL-VM, okay? But for the sake of simplicity and for what we want to see now, you can think that RAL-VM is just a compiler that compiles all your runnable jar into a native executable. And since it's a native executable, it means that there is no JVM, so less memory, less boot up time. And of course, if we are using less memory, it means that we can increase the deployment density, which means that we can take or programs or services and scale up to more and more instances using the same amount of resources. So let's continue with the demo. Let me show you, first of all, here, okay. I can go, let me show you the application that I've got here in Quarkus, so you can see exactly how a Quarkus application looks like. And here it is. This is the application. And what I want you to notice is that, first of all, this is Java. It's nothing different. And it's just using the enterprise Java APIs that we are used to work with, right? Notice that I'm using CDI spec. I'm just using JAX-RS for getting the endpoint, right? This is from here, JavaX web service RS. Okay, this is the specification for REST easy. sorry, for REST, JAX-RS. Yeah. So you are not learning anything at all, right? It's just Java, and it's just JAX-RS. It's just CDI. It's just JPA, whatever. But let me go here again, and let me show you how to deploy a service. Let me do a key and service list, and let's delete these services. Key and service, delete, return, key and service, delete, oops, return SB. Okay, now, of course, I've got no services. And what I'm going to do is deploy a new Kinetic service. I just need to do this thing, kn service create, and I can put here return minus namespace serverless Kinetic. And finally, I need to set the image that I want to deploy, because remember that with Kinetic, everything is a container image. So I just put in here that I want to deploy the container image that contains the greater version written in Quarkus. So I can just do that thing. Notice that it's going to take a bit of time to deploy it. Well, a bit of time, I mean that 2 or 3 seconds or something like that. Okay. Now everything is configured automatically. I can do kn service list, and notice that I've got the URL. I've not done anything. I've not configured the ingress, the root, whatever. No. I just do kn service create, return this image, and boom, everything is here. Of course, I can do a call to this, and you see that it's working. Now I can do give curl get pod, and we've got here the pod. Okay, so if you want to know how much time it takes this Java process, remember that this Java process is this application to boot up. Okay, give curl logs, C user container. It boot up in 5 milliseconds, right? Keep in mind, Java application with enterprise capabilities, JAX-RS, CDI, JPA, so on, booting up in 5 milliseconds and consuming 20 megabytes of RAM. It's awesome, isn't it? It's, it's the perfect solution for your serverless workloads. So let me show you another example about, for example, revisions, how the revisions works. Let me do kn service delete return, and in this case, let's move to basics and oops, come on. Oh, it's not app, sorry. So it's here now. Now let me show you that you can also deploy your services just using the YAML. It's not necessary to do kn create service, blah, blah, blah. You can also use the YAML file if you like YAMLs. Okay. Yeah, I don't know if you like YAMLs or not, but that's life. This is what we've got these days. I always think that in the computer engineering or software engineering world, we love to complicate things, right? We've got JavaScript, right? We've got YAMLs. We could make it easier, but we like complicate the things. So let's go ahead and say that this is a Kinetic service with this YAML, and yeah, this is, well, the name, and then you put it here, the image, and in this case, you are putting here the liveness proof and the greenness proof, and that's all. If you see that version 2 is exactly the same service, but I am configuring using environment variable, so I'm just changing the prefix. Okay, so this version 2, instead of say hi, it says namaste. So let's deploy this. I can just do kubectl apply -f little service v1, and then I can do kubectl apply -f little service v2. Now, if I do kn service list, you can see that it says that there's greater, that with this URL, nothing new. The latest one is v1. Well, wait a second. Or it's still not now. See that the latest one is v2, right? This is the latest one that I've deployed. And of course, if I do crawl, you'll see that it says namaste instead of hi. Okay, and what else I can do? I can do kn revision list. And what I've got is that v1 it's, it's one of the service. Notice that here it just has one greeter service, but the greeter service has two revisions, greeter v1 and greeter v2, and now I'm sending all the traffic to v1, v2, right? For this reason, if I do a curl, I'm getting namaste. How can I switch from v2 to v1? Maybe because I found a bug in the new version. I want to roll back to the previous version. Okay, let me apply this YAML, and now I show you the YAML. Basically, just need to define a traffic and say that now the current version is greeter v1, and I want to send 100% of the traffic to v1, and I don't want to send any traffic to v2. And notice that this is 100-0, but you could put, for example, 80-20 or 50-50 to do a canary release. But in this case, I'm just redirecting all the traffic from v2 to v1. Of course, if I do here a key and revision list, now you see that all the traffic goes to v1, and of course, we can scroll, and there we go. We've got high greeter all the time instead of namaste. Nice. I hope that you like it. Now, let me show you the last thing before we run out of time. Let me delete. Let me delete this service. Oops. Okay, and now let me show you another example. Let me go to CD scaling, and now I'm going to deploy a new service. And here it is. Okay, basically what I'm saying is that I want to deploy this service with this liveness proof and readiness proof, but when I reach the threshold of 10 in-flight requests per pod, so one pod is serving 10 requests, then I scale the number of pods to more pods. Okay, so it's scaling up depending on the requirements of your spike of your traffic. So I can go here. Let me do a kubectl apply -f service 10. So basically, I'm just deploying a new service. Okay, notice that it's still becoming ready, so it's not there yet. But the interesting thing is that now, when the pod receives 10 requests, 10 concurrent requests, then it's going to scale up to more and more pods. Okay, now it's up and running, and I'm going to use Hey. Okay, Hey is just a tool that basically it's going to send 50 concurrent requests during 10 seconds. And let me do a watch here. I'm going to run it. And notice that how it's scaling automatically up. Okay, it's for this reason it's really important also Quarkus. Boot up times really fast to get all these services boot up really quickly to consume all this extra workload that I'm having, and low memory. Since I've got low memory, it means that I can increase the deployment density, and it means that my service can be scaled up really easily with fewer machines. Okay, now you see this, and you'll see that in one minute or so, all these workloads are going to be scaled down to 0 again. So we're almost done, just for 2 or 3 minutes. Then just, if you are wondering how I can take my Java application, my Quarkus application, and make it native, you just need to do -p native, -d Quarkus native container build equal true, and this will create a native executable to be bundled inside a Docker container. Of course, if you want to create this Docker container or this Linux container automatically and push it to your registry, you only need to do -d Quarkus container image push equal true, and then when you're running your processor, you're going to create a native executable, put it inside the Docker container, and push this container to the registry. And of course, if you want to do even more, and it's deploying your service as a Knative workload, you can just use Quarkus Kubernetes deploy equal true and Kubernetes deployment target knative. And then when you run this, your application is going to be compiled to native, create a Linux container, push it to registry, and deploy it to your Knative environment. But as I said before, Knative also works with eventing, and this is in the Knative eventing part, which basically it's exactly the same thing that I've showed you now, but you are not sending requests directly to the serverless workload, but through an event. So basically, you've got your broker, okay, maybe your Kafka broker, you send an event to your Kafka broker, and then this Knative system is listening this broker and starts sending this message to the Knative services. Okay, so for example, if you receive a message to your broker which contains the word green, then you can configure to send this message to a service that it's called Knative service green, and the same for red or not, or just taking the message and send it to a service. So you can do all this kind of stuff thanks of Knative. And some of the Knative eventing sources, so where you can consume all these events, is GitHub, WebSockets, AWS, SQS, GCP, PubSub, Apache, Kafka, Apache Camel, and also there is these links where you can find more implementations, right? But notice that since there is an integration with Apache Kafka, it means that you can send an event, you can send a message to your topic, and then automatically Knative will take the message, the event from this topic, and will send it to a Knative service, to your serverless workloads, which means that if you start receiving a lot of events, the system is going to be scaled up automatically. And if you stop receiving events, then the system is going to be scaled down until 0. And that's all. If you want to learn more, you've got these links: Kinetic tutorial, Kubernetes tutorial, ISO tutorial, and Quarkus tutorial to learn all this stuff. And thank you very much. Remember to rate my talk.
Okay, that was the end of the talk from Alex. And now it's time for the Q&A part. Unfortunately, Alex wasn't available to join us live for this Q&A session. So one of his colleagues, Kamesh, is joining us today to answer any questions that you might have. And the first question I want to ask you, Kamesh, is, would you consider Kubernetes jobs as serverless workloads?
Actually, we cannot call them technically because, as I answered on the chat, the principal reason being that jobs, once get executed, they have to be deleted and restarted. And they cannot scale automatically as well. And then they cannot spawn up, as Alex was showing on his session, right? We can scale up and scale down. So those things are not possible. And these are something like, for example, I cannot trigger a job by sending a REST request or by an event. So those are also not possible. So which we can technically imagine that to be like a serverless thing, but jobs doesn't qualify to be called a serverless.
Okay. Well, thank you very much. There's no other questions, but you'll be here. So if anyone has any other questions, you can contact Kamesh via chat. Thank you again, and relay our thanks to Alex, if you will, please. Thank you very much.
Sure.
Hey team, I know all of you have heard we're talking to potential new customers about the Travel app. So the new plan is to open it up as a service and launch by this summer. Look, I know this is a big request for a not very big team. I'm open to any and all ideas.